If you were standing in space somewhere between Earth and the Sun, looking at the inner solar system, two planets would immediately stand out: Earth and Venus. They are almost the same size. They formed at roughly the same time. In many ways, Venus is Earth's closest sibling. And yet one of them became a blue world filled with oceans, forests, and life. The other became something far more terrifying. A planet where temperatures reach 465 degrees Celsius, hot enough to melt lead. Where the atmosphere is 90 times thicker than Earth's. Venus is often called Earth's evil twin, but the real story is even more unsettling. Because Venus is not just another hostile planet in the solar system. To understand how a world so similar to ours turned into a planetary furnace, we need to go back more than 4 billion years, to the chaotic birth of the solar system. 4.5 billion years ago, the young sun was surrounded by a swirling disk of gas, dust, and debris. Inside this disk, gravity slowly pulled particles together. Dust clumped into pebbles, pebbles became rocks. Rocks collided to form asteroids, and over millions of years those asteroids merged into planets. And for a brief moment in cosmic history, Venus and Earth may have looked remarkably similar. Planetary scientists believe that early Venus may have had liquid water, volcanic activity, and a thick atmosphere, capable of supporting clouds and rain. Computer models even suggest that Venus could have remained habitable for billions of years. Some studies propose that shallow oceans might have existed there for as long as 2 billion years. If that is true, then Venus may once have been a blue world. Perhaps even a place where primitive life could have emerged. So what happened? Why did Earth become a thriving biosphere while Venus transformed into the most extreme greenhouse world in the solar system? The answer lies in a powerful chain reaction known as the runaway greenhouse effect. The greenhouse effect itself is not inherently dangerous. In fact, without it, Earth would be a frozen world. But on Venus, this process spiraled completely out of control. Venus orbits about 40 million kilometers closer to the Sun than Earth. That difference means it receives nearly twice as much solar energy. At first, this probably caused only a modest increase in temperature. But over millions of years, it triggered a dangerous feedback loop. As Venus warmed, water from its oceans began to evaporate. Water vapor is itself a powerful greenhouse gas. As more vapor entered the atmosphere, it trapped additional heat. This caused temperatures to rise further, which caused even more evaporation, and the cycle continued. Ocean after ocean slowly evaporated into the atmosphere. Clouds thickened, the air grew denser, and temperatures climbed higher and higher. Eventually, the process reached a catastrophic tipping point. All surface water boiled away completely. Solar radiation then split the water molecules apart. Hydrogen, the lightest element, escaped into space. Oxygen reacted chemically with rocks on the surface, and Venus lost its oceans forever. Today, the atmosphere of Venus is composed of roughly 96% carbon dioxide. That gas traps heat with extraordinary efficiency. The result is the most extreme greenhouse environment in the solar system. Surface temperatures on Venus reach about 465 degrees Celsius, that is hot enough to melt lead. Incredibly, Venus is actually hotter than Mercury, even though Mercury orbits much closer to the Sun. If you could somehow descend through the thick clouds of Venus toward the surface, the first thing you would notice is the pressure. At ground level, the atmospheric pressure is about 92 times stronger than Earth's. A human exposed to such pressure would be crushed almost instantly. But pressure is only part of the problem. The atmosphere itself is extremely toxic. It is composed mainly of carbon dioxide, along with sulfur dioxide and other corrosive gases. Above the planet float thick cloud layers, stretching for dozens of kilometers. But these clouds are not made of water, they are made of droplets of sulfuric acid. Yes, the clouds of Venus are essentially clouds of acid. Because the heat of the lower atmosphere evaporates the droplets before they can fall all the way down. An endless circulation of corrosive chemicals drifting through a toxic sky. If the atmosphere of Venus is terrifying, the surface of the planet is no less extreme. For centuries, humans could only guess what Venus looked like beneath its thick clouds. The planet's atmosphere is so dense that visible light cannot penetrate it. But in the early 1990s, NASA's Magellan spacecraft revealed the hidden landscape using radar. The images it returned were astonishing. Venus is covered in vast volcanic plains, stretching for thousands of kilometers. Gigantic shield volcanoes rise above the surface. Lava domes and fractured ridges twist across the terrain. Some volcanoes on Venus are enormous by Earth standards. One of the largest, called Mothman's, rises nearly 8 kilometers above the surrounding plains. Recent studies even suggest that some of these volcanoes may still be active today. The entire surface of the planet appears relatively young, perhaps only 300 to 600 million years old. That is surprisingly recent on geological timescales. Scientists believe Venus may undergo periodic resurfacing events. During these events, massive volcanic eruptions flood huge regions with fresh lava. Entire landscapes are buried and rewritten, mountains collapse, plains form. And the geological clock of the planet is reset. All of this happens beneath a sky filled with acidic clouds and crushing pressure. Despite these extreme conditions, humans have attempted to explore Venus directly. The most successful missions came from the Soviet Union during the Cold War. Beginning in the 1960s, the Soviets launched a series of spacecraft known as the Venera missions. Many failed. Some probes were destroyed during entry into the atmosphere. Others lost contact before reaching the surface, but several succeeded. It transmitted data from the surface of Venus for 23 minutes before the harsh environment destroyed it. Later missions improved on the design. Venera 13, launched in 1981, survived on the surface for more than 2 hours. It sent back the first color images ever taken from the surface of Venus. Those images revealed a barren landscape of flat rocks scattered across dusty ground. The sky appeared orange, dim, and hazy. The horizon looked like a volcanic desert under constant twilight. Even the toughest Soviet landers could not survive for long. No spacecraft has ever survived on the surface of Venus for more than a few hours. It remains one of the most hostile environments humanity has ever attempted to explore. Yet Venus still holds mysteries, some of them deeply surprising. In 2020, scientists studying the atmosphere of Venus announced a controversial discovery. Using powerful telescopes, they detected traces of a gas known as phosphine. On Earth, phosphine is commonly associated with microbial life. It can be produced by certain biological processes in oxygen-poor environments. The discovery sparked immediate excitement. Could Venus still harbor life? Not on the surface, conditions there are far too extreme, but perhaps higher in the atmosphere. About 50 to 60 kilometers above the surface, temperatures and pressures become surprisingly similar to those on Earth. At that altitude, the environment is relatively mild. Some researchers have proposed that microscopic organisms could survive there. Tiny microbes floating inside droplets within the cloud layers, drifting through the atmosphere like microscopic balloons. However, the phosphine detection remains controversial. Some scientists believe the signal may have been misinterpreted. Others suggest unknown chemical reactions could produce the gas without life being involved. NASA and the European Space Agency are planning new probes to study Venus in the coming decades. Because despite its hellish appearance, Venus may still hold important secrets. And those secrets could help us understand something crucial. Not just about Venus, but about Earth itself. Venus is more than just a hostile planet. It is a natural laboratory for studying extreme climate evolution. It shows us what can happen when greenhouse warming runs completely out of control. On Earth, greenhouse gases like carbon dioxide are increasing. The processes that transformed Venus took millions of years and required conditions far more extreme than anything occurring today. But Venus still serves as a powerful reminder. Planetary climates are delicate systems. Small differences in energy balance can trigger massive feedback loops. And once certain thresholds are crossed, reversing those changes can become extremely difficult. In other words, Venus shows us what happens when a planet loses control of its climate, a world that may once have had oceans. A world that may once have been habitable, now transformed into a furnace. The hottest planet in the solar system, a planet that rains acid. A planet where spacecraft survive only for minutes. A planet that might once have looked remarkably like Earth, which leaves us with a haunting question. If Venus and Earth began so similarly, how close did our planet come to sharing the same fate?